we're going to start taking a look at how to utilize technology to be able to solve ordinary differential equations as well as systems of ordinary differential equations. And then from there, what we're going to do is we're going to use the technology to help us to be able to solve applications of these systems. So let's just start with one of the most easy computer algebra systems to use. We're going to use Wolfram Alpha. All right. And the reason I like to use this is because we don't need to have a lot of programming experience, nor do we have to be able to know a lot about data structures to be able to run it. So we're just going to use our browser. We're going to go to Wolfram Alpha. And what we're going to do is we're just literally going to type in the differential equation. And we're going to type in solve parenthesis y prime plus 2 over t times y equals t minus 1 plus 1 over t, and the initial value is y at 1 equals 1/2. And then we're just going to execute this. All right, and notice I did forget the parenthesis at the end there, but it fixed it for us. And here's our solution. All right, really nice and easy. So whenever I ask you all to be able to do this type of problem, what you're going to do is you're just going to show me the syntax. So you're just going to copy and paste it. And we're just going to go right here for the code. Okay. So the Wolfram Alpha code is this, and I just did a copy and paste. And then the solution, what you can do really nicely is you can just copy this by going down to plain text. Right? So just click here or go over here and then just click the plain text. And then you can just copy the plain text. And right here is our solution. All right, so really nice. If you want to format it using some sort of formatting, like I know Word has equation, so you could go right up here and you could do like the equation editor if you wanted to, but you don't have to do that. So it can also solve second order differentials. So right here, this is one of our old friends where we might have to use the variation of parameters to be able to solve it. Or if we used undetermined coefficients, it would have that repeated root. So we'd have to have 4x e to the minus x as one of our solutions, all right, or our particular solution. But Wolfram Alpha, really nice. So let's go ahead and solve. So we're going to have solve y double prime plus 2y prime plus y is equal to 4. And I just like to use exp instead of e to the x, right? And just to verify that that is the correct differential. Right? So 4e to the minus x, and then y double prime, 2y prime, y. Right? And then we're going to hit enter. And it solves it right here. It gives us our general solution. So c2 e to the minus x, x, c1 e to the minus x, and then 2e to the minus x, x squared. Right? So we had to actually, if we were to solve this by hand, our particular solution would have an x square in it. Right? Just like we did before, we're going to copy the code. Right? So here's our Wolfram Alpha code. And then our solution, we can just copy that once again. So we can just go into here. And we can just copy this right here. We'll just plain text it. We'll click on it. It's now copied to the clipboard. And we can just paste it right into our Word document. Okay, so really cool. Again, we probably have to do a little bit of formatting. All right, so if we want to get rid of like these underscores, all right, but generally it should be pretty easy for us to use. A system is just as easy to be able to solve. All right, so let me illustrate the code for that. What you guys are going to do is you're just going to go back to Wolfram Alpha, and we're going to type in solve, and we're just going to type in each of the differential equations that can constitute the system. So x prime equals minus 3x plus 2y, and then a comma, and then y prime is equal to minus 3x plus 4y. And we have the initial condition that y at 0 is equal to 1, and x at 0 is also equal to 1. All right, and then we're just going to execute this by hitting enter. All right, and here's our two solutions. All right, so this is our code. So Wolfram Alpha code is this. And the solutions, all right, because there's an X and a Y, we're just going to copy and paste twice. All right, so one of them is going to be this. So our plain text, we're going to copy it, give it a word, and we're going to paste it. And then we go back, and we're going to go down here to Y. We're going to plain text it, and we're going to copy Y, and we are going to paste it. And there's our solution. Right? Same thing for this guy. Even though it's a little bit uglier, we can still render the solution very easily using Wolfram Alpha. And so we're going to type this in. So go back up here. So we're going to solve x prime is going to be equal to, or I'm sorry, x prime plus 3x plus y prime equals 1, comma, and then x prime minus x plus y prime minus y is going to be equal to exp of t. And we have our initial conditions. We have x and y at 0 are equal to 0. Hopefully I typed all that in okay. All right, and there's our solutions, okay? I do remember earlier in the semester, this was actually a problem that we actually solved by hand using either the elimination or the substitution method. All right, so now we can see that we can check these using our Wolfram Alpha. All right, so just like we did before, we're going to copy the code over. So here's our Wolfram Alpha solution, or alpha input, and solutions are going to be, we're just going to copy and paste just like we did before. So it should be fairly easy at this point. So we'll copy it, we'll paste it. It didn't copy. I guess I didn't click in the box. So let's try one more time. We're going to click here and we're going to paste it. And then we're going to go back and we're going to copy one more. And we're going to paste it. We're going to try again. Apparently I can't copy and paste things. There we go. One last time. There we go. Okay, so hopefully this is helpful for you to be able to solve these differential equations using a very powerful tool, Wolfram Alpha, and then also see how to check your solutions to the systems as well as just the ordinary differentials. Now in the next section, what we're going to do is we're going to start applying the systems, all right, much like we did for first order and second order differentials, is we saw applications. We're going to now take a look at applications of systems.